Guys, now we're looking at this question, which is question 5. It goes as follows: 5 South Africans, 3 British citizens, and 4 Germans and 2 Americans arrive for a congress. Okay, they arrive at the congress for then 5.1.1. In how many ways can they be arranged if there's need to set in each other in a row? Then how many are they? If we can count, we have 5, we have 3, we have 4, we have 2. Counting them, we have 14. All of them, we have 14. So the arrangement of them is just 14 factorial. If you can say 14 factorial, we found what? 8, comma, if you can round off, so 72 times 10 into exponent 10. That is the arrangement that we can make. Go to 5.1.2. In how many ways can they be arranged so that those of the same nationality sit together? Then now they are sitting together. So 5 South Africans are gonna be together, 3 British are gonna be together, Germans and Americans. So now we have 5, 1, 2, 3, 4, 5 South Africans. Say these are South Africans, and then we're gonna have 1, 2, 3. We have 3 British, these ones, and then now we're gonna have 1, 2, 3, 4. I'm gonna have 4 Germans, and then now I'm gonna have 2. Just gonna do it with this one, 2 Americans. This is how I have. So remember, South Africans, they're gonna arrange themselves inside this box. British are gonna arrange themselves also inside here. Germans also, they're gonna arrange themselves inside here. Also the Americans, they're gonna arrange themselves inside here. So I need to do the arrangement inside here, inside here, inside here, inside here. Now South Africans, they are 5, so I'm gonna have 5 factorial in South Africans. It's 120. British, they are 3, so I have 3 factorial in British, which is 6. And then also the Germans, they are 4, so we're gonna have 4 factorial for the Germans, which is 24. Then Americans, 2 factorial, which is 2. 2 factorial, it's what? It's 2. Now again, they are sitting together, so these people, they are one group. If they move as a group. If they come here, let's say South Africans wants to come here, they're gonna come as a group. They're gonna sit here as a group because they have to be next to each other. So I'm just gonna say this: 1, 2, 3, 4. So I also need to find the arrangement of them as a group, which is there 4. So as a group now it's 4 factorial also, which is what? Which is 24. Now I need to times all these possible arrangement here to find one possible way. So it's going to be 5 factorial times 3 factorial times 4 factorial times 2 factorial, and also times this 4 factorial, which gives me what? 5 factorial times 3 factorial times 4 factorial times 2 factorial times 4 factorial, which gives me 8294440. So this is the arrangement that has happened here. Okay, now going to 5.2, which is saying consider the letter word of probability. Let me write down this word. Then let's go to the question now. They're saying how many unique word arrangement can be made from this word if the repeated letters are to be treated as what? As identical. So now how many letters do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 letters. So I have 11 factorial. But now remember, in this word there are letters that are repeated. So I have B that is being repeated here. So I have B that is repeated. So I need to divide with the letters that are repeated. So divided by 2 factorial of B that is being repeated, and then times. And then also not only B, I also have I here and I here, which is repeated. So I'm gonna times with also that I that is what? That is being repeated there. And then let's find now the arrangement of that letters. So 11 factorial all over 2 factorial times 2 factorial, then I get what? I get 9, 9, 7, 9, 2, 0, 0. So this is what I get. And then 5.2.2, now it's saying how many unique word arrangement can be made if the word ends with R. This word, it's gonna end with R. So let me just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now there are 11 letters here. Now they are telling me here at the end R is gonna be here. So I'm gonna use R here. So which is 1, which is the only option I have, R, because I have only 1 R there. Now how many letters there are left if I have already used what? I've already used R. I have 10. So it's gonna be 10, sorry, it's gonna be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. From 10 to 1, okay, we times from 10 to 1, that is 10 what? Factorial, also times what? This 1. We are not done. We are not done. From this word, because we are still talking about this word, there are letters there that are repeated. We have B that is repeated. We still have I that is repeated. So it's gonna times, we're gonna divide with those letters, which is B that is being repeated, times what? That I that is what? That is being repeated there. And then we find our answer, which is what? 10 factorial times 1 all over 2 factorial times 2 factorial. What do we get? We get 97200. So that is the arrangement that we get if we end with what? With the letter R. Okay, thank you guys. Now question 7, which states like consider the letters of word Merafong. So we have this word which is ERAFONG. We have this word, and then now they are telling us that how many unique arrangement can be made using these letters. The letters, one of the most important thing, the letters may be repeated. Now how many letters do we have here? 1 2 3 4 5 6 7 8. So it's 1 2 3 4 5 6 7 8. These letters may be repeated. So we have 8. It's gonna still have 8 8 8 8 8 8 8. These letters may be repeated. So we times it. 1 2 3 4 5 6 7 8 with 8 raised to 8 times in the same base we add the exponent. I hope you still remember that one. So now if we have 8 raised to 8, we have 1 6 7 7 2 1 6. How many 7 do I have? I have 3 7s. Sorry about that. And then we have 7.1.2, which states as now calculate the probability that the weight arrangement will start with R and end with what? With N. So how many letters do we have? We have 8 of them. So 1 2 3 4 5 6 7 8. Now they are telling us that here we're going to start with what? With R. So we have R here, and then they are telling us that we're gonna have N here. So 1 R is gonna be here, and then 1 of N is gonna be here. This one is fixed, like it or not. They are going to be here. From 8 letters, I've already used 2 letters. How many it's left? From those letters, 6 letters are left. So from 6 7 6 5 4 3 2 1. Then from 6 to 1 here, times in this, it's giving me what? 6 factorial times this one, and then also times this one is just 6 factorial which is what? 720. But remember, I'm looking for what? For probability. So I haven't answered the question. I need to find the probability, but now I need to find the total arrangement of these letters. Here I did find it, but now the letters may be repeated, but I can't use it here in terms of finding the probability. I need to use them when the letters are not repeated. So how many letters do I have? I have 8 letters. So I need to find that one, which is 8 factorial, which is my answer. It's going to be, now this is one of the arrangement that need to be made with these letters, but this one, the letters are not repeated. Don't forget that one. Don't confuse when you're finding the probability. We are using the one where the letters are not repeated. Then now if I find the probability now of these arrangement letters is what? Now remember, it's the arrangement that we want, which is this one, which is 7 20 all over the total arrangement. This is the restriction that they gave us all over the total arrangement, which is 40320. Then it's giving us 720 divided by 4320. It's giving us 1 over 56. So this is the probability that they want here in 7.1.2. Now coming here in 7.1.1.3, they are telling us now also calculating the probability. Now in this probability, they are telling us that the vowels will be placed next to each other. Now let's place the vowels of this word. It's gonna be A, E, O, and then grouping these vowels because they are telling us that they're gonna place next to each other, and then the following letters is just gonna be M, R, F, and G. These are the following letters. Now remember, these vowels are gonna be placed next to each other. Like it or not, now these vowels are on the box. They're gonna be placed next to each other. So inside of this box, there's gonna be an arrangement of these vowels. So now we need to find the arrangement of these vowels, which are 3. So it's just gonna be 3 factorial, which 3 factorial is 6. So we find 6 from the answer of this 3 factorial. Now this box now we consider as one box, so it's gonna be 1 and then 2, 3, 4, 5, and 6. So now the arrangement that is going to happen here, including this box, but this box, that's why I make it 1, because now it's a 1 box inside of the vowels. I do have the arrangement of the vowels that are inside the box. This is the arrangement of the vowels that inside the box, but also the box is going to move also in between of these letters. So that's why I also count what the box. So how many I have here? I have 6, so it's gonna be 6 factorial, which gives me what? Which gives me 720. So now finding the probability. Now remember, I still have to say 6 factorial times 3 factorial times this 6 factorial, which gives me, now finding the arrangement here is 4320, but now I'm looking for probability. So the probability, it's saying the restriction that they gave us here in terms of the arrangement is 4320 over the total arrangement, the possible total arrangement. We found it here, which was 8 factorial, which was 40320, which gave us the answer of 4320 over 40320, which is 3,28. So this is the probability that we are looking for. Thank you so much.